Okay, question 9, we can see this is going to be coordinate geometry, and they've been really kind and given us a diagram, so that's a good start. Okay, so we read the words, we've got a line, we've got an equation of L1, and then we've got some trigger words, we've got perpendicular, and we've got passes through the origin O. And from that information, you're almost guessing what the first part of the question is going to be before you read it. Oh yes, we've got to find an equation of a line. So that's trigger phrase, equation of a line. We know we need a point, and then we're going to have a gradient, and from those two things, we're then going to go into the y minus y1 recipe. Okay, so what point do we need? Well, we've got a point, that's very easy. What gradient do we need? Well, perpendicular to L1. So that's how we're going to finish. We're going to find a perpendicular gradient. But then we have to look at L1. There's L1. Okay, how do I get the gradient of L1? Well, this is an equation, but it's not in the form y equals mx plus c. So the three methods for gradient, there's a 2-point method for gradient. Well, I haven't got 2 points on any line, so I'm not going to use that. Differentiation is not relevant in this question. It's a straight line gradient, so it's the third method for gradient, y equals mx plus c. Get the gradient of L1 first. So you get the gradient of L1 but after rearranging it into y equals mx plus c, and then you need to remember to get the perpendicular gradient. Okay, and that's the gradient you need for your y minus y1 recipe. Okay, and the point's easy because it's here. All right, so that's the first part. Okay, now even if you haven't got an answer to the first part, or even if you've got it wrong, you want to follow through. So get some kind of equation for L2 in the second bit, because we need it here. We've got a trigger word here, intersects. Intersects means we're going to be solving simultaneous equations. So there are going to be some marks for solving this equation. So we've got L1 and L2, okay, are intersecting. So it's those two equations we need. So L1 we were given, L2 you've got the equation for here. So those are the two equations you need to solve simultaneously. And even if this is a horrible, wrong, made-up equation in part A, you can still, as long as it's in the right ballpark, get some credit for trying to solve these two simultaneously. Okay. Also, all right, so that's going to be about the point C. We haven't even read the question that's coming, but we kind of know that we're going to be interested in C. We also think we're going to be interested in the point B. Why? Let's read it properly. We want the area of triangle OBC. This is where you would need to draw a diagram if they hadn't kindly done it for us. But this is the triangle we want the area of. Okay, and look, these 2 points, if I can get the coordinates of each of these, then this length here, I'm just going to need to know that that's the origin, and if I know what the y coordinate of that point is, okay, at B, then that's going to be helpful. And C, I'm going to be interested in its coordinates as well, because in fact it's mainly the x coordinate I'm going to be interested in, okay, because that measurement there, okay, if I turn the diagram sideways, those two red lines, if you look at the diagram this way on, are the base and the height of the triangle. So when we've got triangles on diagrams, very often we'll have to turn the diagram round till we find the best side for the base and the best way to have the height perpendicular to that. So those are the two measurements we want, and we know that they can come from the coordinates of B and the coordinates of C. So, going back to the information we're given, we've said the point C is this intersection, so that's simultaneous equations. The point B, completely separate, okay, is just where L1 crosses the y-axis. So it's a y-intercept, and that's a trigger. Okay, how do I find the y-intercept? Well, I get the equation, and the y-intercept is when something equals 0 in that equation. So put that thing equals 0, solve for y. The y-coordinate of B on its own is worth 1 mark, which is worth getting. So once you know the y-coordinate of B, that's going to help you with this measurement of the triangle. And once you know the coordinates of C, in particular the x-coordinate, that's going to help you with this distance. So you're going to be able to plug those into the area of a triangle formula, which is what you need to do in part B. So this 6 marks, it's quite easy to start earning these 6 marks, and it's not all that difficult if you do what I've described to get 6 out of 6 and 10 out of 10 on that question. We're beginning to get into the later stages of the paper where the marks you get there are going to really push you up the grades if the first half of the paper's gone well for you.